Namaste, Rakesh Ram Tripathi, welcome back. In previous lecture, I discussed uh, exercise 3.3, question 1 to 5. Now the next question is question number 6. We have to prove the left hand side given cos pi upon 4 minus x, cos pi upon 4 minus y, minus sin pi by 4 minus x, sin pi by 4 minus y. Let pi upon 4 minus x a and let pi upon 4 minus y b. So you can apply the formula cos a cos b minus sin a sin b, that is cos a plus b. So cos a means what? Pi upon 4 minus x, and b means what? Pi by 4 minus y. So pi upon 4 plus pi upon 4, that will be pi upon 2 minus common x plus y. So you can apply the formula cos 90 minus theta. Cos 90 minus theta is what? Sin theta. So sin x plus y. One more formula you can apply, you can multiply with half and then 2. So 2 cos a cos b you can apply, but this one is more easier. Question number 7. Left hand side given tan pi upon 4 plus x upon tan pi by 4 minus x. We have to prove 1 plus tan x upon 1 minus tan x whole square. Very simple, you have to apply the formula tan a plus b. So tan a plus tan b upon 1 minus tan a tan b. Denominator, it's a tan a minus b, so it will be tan a minus tan b upon 1 plus tan a tan b. So tan pi upon 4 what? 1. So 1 plus tan x upon 1 minus tan x, and the denominator will be 1 plus into, instead of this division sign, put multiplication, reciprocal of denominator, 1 plus tan x upon 1 minus tan x. So 1 plus tan x in the numerator, 1 plus tan x twice, so it will be whole square, denominator 1 minus tan x, it will be whole square, so you can write 1 plus tan x upon 1 minus tan x whole square. That is right hand side proved. Question number 8. Cos pi plus x cos minus x upon sin pi minus x cos pi by 2 plus x. So cos 180 plus theta. Pi plus x means cos 180 plus theta. It will lie in third quadrant. Tan cot plus, this will be minus, so minus cos x. Cos minus theta, it will lie in fourth quadrant, so cos x. Sin 180 minus theta, second quadrant, it will be plus sin theta. Cos pi by 2 plus x, 90 plus theta, second quadrant, sin cos x plus, cos will be minus in terms of 90. For in this case, 90's case, cos will convert in sin, so minus sin x. So cos square x upon sin square x, it will be cot square x. Similarly, question number 9. Cos 3 pi by 2 plus x, cos 2 pi plus x, cot 3 pi upon 2 minus x plus cot 2 pi plus x. So cos 3 pi upon 2 plus x, it will be sin x, and cos 2 pi plus x, it will be cos x. Similarly, cot 270 minus theta, it will lie in the third quadrant. So tan x, cot and tan plus, and cot 2 pi plus x, it will be cot x. So you can we can convert tan and cot in terms of sin and cos. Take LCM. Upper part will be sin square x plus cos square. Denominator get cancelled. 1 right hand side, hence proof. Question number 11. Cos 3 pi upon 4 plus x minus cos 3 pi upon 4 minus x. I have applied the formula cos c minus cos t. You can apply one more formula, I think cos a plus b also, but I have applied cos c minus cos d. C is what 3 pi upon 4 plus x, and d is what 3 pi upon 4 minus x. So minus 2 sin c plus d by 2, sin c minus d by 2. X and x get cancelled, 3 pi upon 4 plus 3 pi upon 4, 6 pi upon 4. Similar to this, sin 2x upon 2, so sin x. So get cancelled, 6 pi upon 4, 2 to ya 4, this 4 into 2, 2 3 is 6, so 3 pi upon 4, and that will be 1 upon root 2. Cos 3 pi upon 4, it will be 1 upon root 2 sin x. So minus, rationalize the denominator, you will get minus root 2 sin x. Question number 12. Left hand side given sin square 6x minus sin square 4x. So we can't apply any formula over here, means we know the formula for sin, sin c minus sin c plus sin d, sin c minus sin d, but this is the square. So first we apply algebraic identities, a square minus b square. So it will be a minus b and a plus b. So sin 6x minus sin 4x. So sin c minus sin d, it will be 2 cos c plus d by 2, and sin c minus d by 2. Sin c plus d is what? 2 sin c plus d by 2 cos c minus d by 2. So 6 plus 4 10, 10 upon 2 5x. 6 minus 4 2, 2 upon 2, that is x. Sin c plus d, 2 sin c plus d by 2, 10 upon 2 5, and 6 minus 4 2x upon 2 x. So 2 sin x cos x, 2 sin 5x cos 5x. Means we can apply 2 sin a cos a, that is sin 2a, and here 2 sin a cos a. So a means what? 5x, 5x. So sin 2a, sin 2 into 5x sin 10x. Right hand side hence proved. Question number 12. Left hand side given sin 2x plus 2 sin 4x plus sin 6x. So we can apply sin c plus sin d, but it's very important to identify which two terms we should combine to apply the formula sin c plus sin d. So sin 2x and sin 6x. This is what 2. 2 is the coefficient. 2 is retained as coefficient of sin 4x. So first, means we can't apply sin c plus sin d. This 2 we have to remove from here. Then you can apply. So I have combined sin 6x. So sin c plus sin d. 2 sin c plus d by 2 cos c minus d by 2. Now see, in the first it's given 3 terms. Now we have converted in the third step. Now we have converted in 2 terms. So 2 sin 4x cos minus 2x and 2 sin 4x. So 2 sin 4x common. You will get cos 2x, cos minus theta, cos 2x plus 1. Now put the value of cos 2x in such a way 1 should get cancelled. So cos 2x is 2 cos square x minus 1 plus 1, 1 get cancelled. And now you can write 4, 2 2 is 4, 4 cos square x sin 4x, right hand side hence proved. Question number 16. Cos 9x minus cos 5x upon cos sin 17x minus sin 3x. Applies cos c minus cos d. Minus 2 sin c plus d by 2 sin c minus d by 2. Here also sin c minus sin d. So 2 cos c plus d by 2 sin c minus d by 2. So apply the, it will be sin 7x, get cancelled, sin minus sin 2x upon cos 10x. This is the right hand side. Be proved. Question number 20. Sin x minus sin 3x upon sin square x minus cos square x. Sin c minus sin d. So 2 cos c plus d by 2 and sin c minus d by 2. Minus common cos square x minus sin square x, cos 2x. So now it will be 2 cos 2x sin x. Cos 2x and cos 2x get cancelled. You will get 2 sin x, right hand side hence proved. Question number 21. Cos 4x plus cos 3x plus cos 2x upon sin 4x plus sin 3x plus sin 2x. Here also we need to combine any 2 terms to apply the formula cos c plus cos d or sin c plus sin d. If you combine 4x and 3x, you will not get a whole number. 4 plus 3 7, 7 upon 3 2.5. If you combine 3x and 2x, you will not get whole number after applying the formula. So I have taken cos 4x and cos 2x in the numerator, and in the denominator sin 4x and sin 2x I have taken. So cos c plus cos d, 2 cos c plus d by 2, cos c minus d by 2. And similarly here sin c plus sin d, 2 sin c plus d by 2, cos c minus d by 2. So in the numerator it was given the first step. You can see there are total 3 steps are given. After applying the formula, we got means we have converted in 2 terms, and in the third step you can see over here we can take common cos 3x common. In the denominator also we can take common, so sin 3x. So in the numerator 2 cos x plus 1 upon 2 cos x plus 1, so that is cancelled and we got cot 3x. Question number 22. Cot x cot 2x minus cot 2x cot 3x minus cot 3x and cot x. So first we need to apply the formula. It's what I have done here. In the last two terms, look at here, cot 3x common. So we got cot 2x plus cot x. Now we need to simplify cot 3x in such a way. Cot 2x plus cot x should get cancelled. So what I did, 3x I have split 3x, 2x plus x in the form of 2x plus x, and now apply the formula cot a plus b, cot a cot b minus 1 upon cot a plus cot b. So this part get cancelled. Now in the numerator, this part will be minus multiplied with cot 2x cot x minus, and minus multiplied with minus, it will be plus 1. Again the first 2 part get cancelled and 1 is the right hand side. This is the final answer. Question number 23. We have to left hand side given tan 4x, and we have to prove 2 tan x 1 minus tan square x upon 1 minus 6 tan square x plus tan raised power 4x. So tan 4x we don't know the formula for tan 4x, but we know the formula for tan 2x. So we have to split tan 2 into 2x. So tan 2x is what? A. So 2 tan a upon 1 minus tan square. Now again apply the formula for tan 2x. So 2 tan a upon 1 minus tan square. Here also 2 tan a upon 1 minus tan square whole square. Now it will be 2 tan x upon 1 minus tan square x. And the denominator, you need to simplify this. The denominator, it will come like this, it will be like this, 1 minus tan square x whole square, and this part will be 1 minus tan square x whole square minus 4 tan square x. What I did, I took LCM over here, 1 minus tan square x whole square, and then reciprocal. So this part will be 2 tan x 1 minus tan square x upon apply the formula a minus b whole square, and then this will be the answer, right hand side, 2 tan x 1 minus tan square x upon 1 minus 6 tan square x plus tan raised power 4x. Question number 24, similar problem, cos 4x, we don't know the formula, we know the formula for cos 2x, so you can write like 4x 2 into 2x, this 2x a. So cos 2x, see the right hand side we have to bring right hand side in terms of sine and cos. So cos, and it's written 1 minus 8 sin square x cos square x. So you have to write the formula 1 minus 2 sin square x. Cos 2x is equal to what? 1 minus 2 sin square x. If the same result given 8 sin square x cos square minus 1, then you will write 2 cos square x minus 1. Now this sin 2x will be 2 sin x cos x whole square. 2 to the 4 sin square x, and then 4 to the 8, right hand side, hence proved. Question number 25, cos 6x. You can write cos 3 into 2, cos 3a. We know when you can write cos 2a also. Then here 2 will come and here 3 will come. So cos 3a, a means 2x. So 4 cos cube a minus 3 cos a. Cos cube, cos 2x, 2 cos square x minus 1. The whole result, the result which we have to prove, it's given in terms of cos. So each and every term we have to write in terms of cos only. So 2 cos square x minus 1 whole cube minus 3 cos square x minus 1. Apply the formula a minus b whole cube and then simplify. You will get this answer. There are some important problems, extra problems I'm giving over here. This is for triangle, In a triangle, the sum of all 3 angles 180 degrees. Given a plus b plus c is equal to pi, prove that sin 2a minus sin 2b plus sin 2c is equal to 4 cos a sin b cos c. So sin 2a, take the left hand side, sin 2a minus sin 2b plus sin 2c. So apply the formula sin c minus sin d, 2 cos c plus d by 2 and sin c minus d by 2. Now a plus b plus c is equal to pi. So a plus b you can replace. A plus b equal to, you can write pi minus c. I have written from here this result, pi minus c. So cos 180 minus theta minus cos theta, second quadrant sin and cosec plus. Here a minus b you can't replace, plus 2 sin c cos c. Now this is the first term and this is the second term. In both the term 2 cos c is the common. So minus 2 cos c you can take common. Here sin a minus b minus sin c. Now here sin c minus sin d would be better if c instead of c a plus b given, right? So what we will do, we will try to convert c in terms of a plus b. The reason is that if you apply sin c minus sin d over here and here a plus b is given, then a minus b plus a plus b means you will get the next part in the simplest form. So I have written pi minus a plus b. Again with the same result, c is equal to pi minus a plus b. So sin 180 minus theta, second quadrant, sin theta, sin a plus b. So sin c minus sin d, you can apply minus 2 cos c plus d by 2. B get cancelled, 2a upon 2 get cancelled a, and sin c minus sin c minus d. So sin b you will get multiply, you will get the answer right hand side. So instead of a plus b, put pi minus c, and instead of c you can put pi minus a plus b if it is required. Question number 2, same, a plus b plus c equal to pi. Prove that. Again cos 2a plus cos 2b plus cos 2c. Apply cos c plus cos d, 2 cos c plus d by 2 cos c minus d by 2. This cos 2c you can write 2 cos square c minus 1. Now a plus b, instead of a plus b put pi minus c. So cos 180 minus theta minus cos theta, second quadrant sin cosec plus, rest will be minus. So cos 180 minus theta minus cos theta, and then again we have three terms, 1 2 3. One is the separate terms, right? Pure constant term. So now this minus 2 cos c you can take common. This is the first and this is the second. I am combining these two terms. In these two terms, minus cos c common. So you will get cos a minus b minus cos c. So now instead of c, again pi minus a plus b. So it will be cos 180 minus theta, it will be minus cos theta. So minus into minus plus. I have skipped 3 terms. So now cos a plus b, cos a minus b plus, again apply cos c plus cos d. So you will get this answer, and then this is the final answer, right hand proof. Question number 3, similar problems. A plus b plus c is equal to pi. Prove that. So cos 4a, again apply cos c plus cos d, 2 cos, and again instead of 2a minus 2b, here 2a plus 2b, and then 2 cos square 2c minus 1. Here instead of 2a plus 2b you can write 2 pi minus 2c, means 360 minus theta. So it will be cos theta only. Again simplify, and then you will get this result. Question number 4, a plus b plus c equal to pi. Prove that. Sin square a upon 2 plus sin square b upon 2 minus sin square c upon 2 equal to 1 minus 2 cos a upon 2 cos b upon 2 sin c upon 2. So left hand side, sin square a upon 2 plus sin square b upon 2 minus sin square c upon 2. Convert sin square, remove the square from here. So convert in terms of cos. The reason is that right hand side is given in terms of cos. So 1 minus cos a, and we know the formula cos 2a. We know the formula for cos a. Cos a is equal to cos square a by 2 minus sin square a by 2. Cos a equal to 2 cos square a by 2 minus 1 minus 2 sin square a by 2. So instead of sin square a by 2, 1 minus cos a upon 2 sin square b by 2, 1 minus cos b upon 2, sin square c by 2, 1 minus cos c upon 2, and then half. See, you can see half, 1 half and minus half. So half plus half, 1 minus half, and then my 1 by 2 is the coefficient of cos a, cos b and cos c. So minus take common, so cos a plus cos b minus cos. Now again apply cos c plus cos d for cos a plus b. So 2 cos a plus b by 2, cos a minus b by 2, and then cos c you can write in terms of sine, because on the right hand side one term given in terms of one term given sine c upon 2. So cos c we can convert in terms of sine, and a plus b upon 2 you can write pi by 2 minus c. Again the same result you have to apply, a plus the result which is given, a plus b plus c equal to pi. So and then pi upon 2 minus c upon 2, cos 90 minus theta sin c upon 2, again cos a minus b upon 2 is given, minus sin square c upon 2 plus half. I multiplied with half with each and every term. So minus sin c upon 2, cos a minus b upon 2 plus sin c upon 2, again convert c in terms of a plus b, c upon 2 is equal to pi by 2 minus 90 minus 1 plus a plus b by 2. So sin 90 minus theta, it will be cos theta. So cos c plus cos d, so 1 minus sin c upon 2, so 2 cos c plus d by 2, cos c minus d by 2, and then this will be the result. Thank you so much.